Right. Good morning, good afternoon, good evening, everyone. Thank you for joining us for this edition of the MuleSoft Online Meetup. My name is Royston Lobo. I work as a customer success technical architect in Sydney, Australia, and I'm one of the co-organizers of the meetup group. Today we have Susmit Day, who is an architect who works in the MuleSoft space, who's based out of Sydney in Australia. He's taken the time and effort to put together a presentation on custom policies and how it can be implemented. The content for today in terms of the slides and the code will be linked from the event page later today. If you have any questions during this meetup, feel free to type them into the chat, where I will be asking the questions towards the end of the session. Yes, feel free to introduce yourself in the chat as well, where you're joining in from, and any other knowledge that you think that'd be useful in relation to the topic that's being discussed today. So with that, Susmit, please take it away.
Thanks, Royston, and thanks everyone for joining this session. As Royston said, my name is Susmit Dey, and I work as a MuleSoft architect based out of Sydney, Australia. Today, we're going to discuss about custom policies in Mule 4, and we're going to demo a circuit breaker. So the circuit breaker will be a circuit breaker on an HTTP policy that or HTTP flow that we're going to implement in Mule, and we're going to apply a custom policy which will have a circuit breaker on the top of the API. So we'll demonstrate how that works. So we'll go to the agenda. So as part of today's agenda, we will have a brief introduction to API Manager and what are like the policies available in API Manager. And then we'll understand the policy architecture, just the basics of it. We'll revisit a very basic functionality, which we probably already know, called auto discovery. We'll see what are resource level policies, and then we'll go into the main agenda for today, which is the custom policies. As a part of that, we'll see how we set up custom policies, how we deploy it, what are the key artifacts which are part of the custom policies. And then we'll go into a circuit breaker demo, which is implemented using custom policy. There is an additional demo, which is a Salesforce OAuth token injector. But if the time permits, we'll go through that demo as well. Okay, so to start with, we have an introduction of what are API Manager policies and how we apply those policies in our APIs. So as you know, policies are extended functionalities that you implement outside your core logic that you implement as part of your Mule application. And this logic, as part of the policies, can be deployed into API Manager and applied on the API. There are some out-of-the-box policies provided by MuleSoft, which you might be already using: client ID enforcement, basic authentication, IP whitelist, blacklist, rate limiting, etc. So the policy architecture is such that we have API Manager, which is part of the API Anypoint platform. And in API Manager, we define API instances. Each API instance will have an API ID, using which we pair with the APIs that we develop and deploy into the runtime. And the way we do it is by specifying these properties in our application. You might be already knowing it. And this is the diagram from the MuleSoft documentation, which talks about how API Manager policies are applied in your API. So there is an auto discovery mechanism using which your API pairs with the API instance in API Manager, and there is a runtime manager agent which downloads the policies and applies on the top of your API, and the component it uses is an embedded API gateway on which it applies the policies. Just to revisit the auto discovery, as I said, you have an auto discovery component in your code which takes an ID, and using that ID pairs with the API Manager instance. And you might be knowing about the concept of gatekeeper. If the auto discovery pairing is successful, only then the policies get applied on your API. But if the API manager policy pairing is not successful, the gatekeeper will block access to your API and it will give a 503 error. These are just revisiting the concepts. Now come to resource level policies. So what are resource level policies? If you have an API manager instance and you want to apply policies onto it, in Mule 3, if you have used Mule 3 and created API instances in API manager, it would not allow you to apply policies at a resource level unless you have a YAML definition of the API. But in Mule 4, even HTTP-based APIs, you'll be allowed to apply resource level policies, so on the resources. So you might be using this feature as well, very common feature. You can define regex expressions to identify the resources in your API. So now we'll move into the main topic for today, which is the custom policies. So as you know, the policies are implemented as extended functionalities, but custom policies, why do you need it? Because these extended policies can be such that these are not provided as out-of-the-box features by MuleSoft. So something you want to do as a part of your customization. So MuleSoft provides all the out-of-the-box policies in API Manager. If there is a requirement, a specific requirement that you have where you need to do a certain, implement a certain logic for API management or on the controlling the traffic or apply any security mechanism, custom security mechanism, or do any housekeeping as such, you might explore custom policies and see if that suffices your requirements. So in Mule 4 onwards, in Mule 3 custom, if you have developed custom policies, you have to upload the custom policy artifacts in the API manager. But from Mule 4 onwards, the custom policy artifacts are deployed into any point exchange. And once you deploy into any point exchange, your API manager will automatically look up for those custom policies from any point exchange. There are two types of custom policies. One is an online policy and another one is an offline policy. Online policies are the ones that you deploy into any point exchange. And through API manager, you apply those policies in your API instance. Offline policies are same policy artifacts which are directly applied on the runtime. Offline policies are helpful when you want to debug your policy locally. So you have a standalone MuleSoft environment, you copy your policy artifacts, generate a jar, there's a deployment descriptor also available, and you put it in a particular folder, and then it gets applied onto your runtime. But of course, since there is no auto discovery mechanism, you need to disable the gatekeeper. So the offline policy is out of scope for this presentation. We're only going to talk about online policies, how you create custom policy projects, what are the key elements defined in the project, how you implement the logic, and then how you deploy it into any point exchange, which is what we want to do. So as I discussed, what are the scenarios in which you want to use custom policies if you have any non-functional requirement which is related to API management, and that feature is not available out of the box by MuleSoft. So you can implement it as a part of your custom policy and apply it on your APIs. There are two types of custom policy implementation. I'll come to that. But one is called inbound policies, the other is called outbound policies. So inbound policies are the ones which are applied on incoming traffic into your API. Outbound policies are the ones which get applied to the outbound traffic, means any outbound calls you make from your API. We'll come to those in details in the following slides. So to start with, in a custom policy project, we mainly have main two artifacts. One is a Mule configuration file having the policy logic. So whatever logic you want to implement in your custom policy will exist in the Mule configuration. And there is a YAML file also which gets generated, and that normally has the definition for all the parameters that you configure as a part of policy UI. When you apply the policy, there is always an UI which pops up, a form which pops up where you enter certain values, and that form can be configured using the YAML file. And the values that you configure there are also available in your policy implementation, policy logic. So we'll see how those values are accessible in your policy. So as you might be knowing, there is a concept of archetype repository. Archetype repository provides sample or template projects. MuleSoft provides this particular URL, which hosts the archetype repository, where you can find template projects, which you can use to generate custom policy projects. So the next steps actually talk about how you configure your workspace so you can create an archetype project, and then we'll see how it looks like. First, you need to have, for archetype project, generating archetype projects, you need to have Maven locally. And then in Maven, you need to configure your settings. You need to put this segment, a particular profile, in your Maven settings, and you'll have an ID for your profile, using which you'll refer to this profile and generate your template project. So this segment goes into your settings.xml. I have it. So this is how you put, this is my settings. It is in the M2 directory, and I put a profile here, right? Okay, go back to the slides. Now this is the command you use to generate a custom policy project from archetype repository. If you see, the -p actually refers to the profile that you have created in your Maven settings. If you see, if it's -p archetype repository, which is the same name you have given to your profile. So you refer to your profile, and your profile has the archetype repository URL, and there you issue a command archetype generate and provide the following parameters or arguments to generate an archetype, to generate a custom policy project. But here is one thing you need to note: the group ID of your Maven project should be the same ID as the org ID of your endpoint platform. So this yellow part, which is highlighted, this has to be the org ID of your endpoint platform. And why it is needed? This is something which is required as a part of your deployment. So when you do deploy your artifacts into Anypoint Exchange, it needs to locate for which org it needs to deploy, because Anypoint Exchange is common feature for different organizations. So you need to specify like your particular org for in which this gets deployed. So this is in your private Exchange portal. And when you generate the project, it asks for the policy description and policy name. You provide those details when you issue this command, and it will generate a custom policy project. So the custom policy project actually looks like this. It has a YAML file which describes the form parameters that you're going to have in the policy UI. It will have a template.xml where you will have the actual policy logic. So as a part of the demo, I have created these two projects, so I can show you what gets generated here. There is a policy YAML which contains all the properties that you define here will be reflected in the policy UI. When you apply the policies, these properties will pop up, and you need to enter values for each of these. And these properties are accessible in the policy logic that gets generated in the template.xml. So this is where you implement your actual policy. And all the configurable parameters that you define in the YAML are accessible here. So we'll come to that part, how you access these properties in the configuration, Mule configuration. Let's go back to the slides. Yeah, so now you know what's the YAML file used for and what is the XML file, the template.xml. Now we have the custom policy setup as you know, you have to deploy to the exchange. So for that, you need to configure exchange as your distribution management repository. What happens when you declare exchange as your distribution management? You issue a maven deploy command. It tries to deploy into your exchange server. So when you configure exchange server, normally this is a maven project, so there will be a pom.xml. And when you go here, you will see there's a property there called exchange.url. And there also you need to give the group ID in here. So there's an URL pattern for your exchange. You need to give the org ID here so that it locates your org's exchange and deploys it there. And in here, you need to also have the distribution management, which means it should locate your exchange, your org's exchange, and then it will deploy into your org's exchange. So these are the configurations you need to do for the deployment, right? So the same is mentioned here. And for packaging and deployment, you just need to issue a maven package command jar. And to deploy it into the exchange, as I said, you already mentioned the exchange URL as your distribution management repository. So when you issue a deploy command, your maven will deploy your policy into the anypoint exchange. And there, after the policy gets deployed, it shows like this. If you have used Mule SDK to develop custom connectors, you can use icons, but unfortunately for policies, it doesn't allow you to actually give an icon. It always looks like this. And I should also mention that each policy has a version number, which is as what is mentioned in the pom.xml. So there is a version. And this deploy step actually releases your artifacts as a custom policy into Exchange. So you cannot deploy the same person multiple times. You cannot replace the version unless you manually delete the artifact from Exchange and deploy the same version again. But the best practice is to have an incremental version every time you make changes into the policy and do your deployment. You can go to Exchange and see how it looks like. So this is a trial account I'm using. Okay, so we'll see in API Manager if we can see the custom policy when it gets deployed. So if you go to policies and you apply policies, you have to select a category called custom, and there are two policies which are deployed in the custom category. And how you mention this category to be custom, that is also available in your policy configuration. So you see the category is custom. You can change it to make other categories, but if you are implementing a custom policy, it's better to use a custom category. It can be security or something else as well. And these policies are available. And if you see, there are different versions of these policies. So this is grayed out because I have applied this policy. You cannot apply the same policy multiple times, but you can apply different versions of the policy in the same API instance. So this shows up. And if you see these policies, you can browse from API Manager. But where it looks up from, it actually looks up these policies from the Anypoint Exchange. So if I go to Anypoint Exchange, you'll see this policy got deployed here. And there are different versions. You can also try to deploy the policy here in a while. Okay, so let's move on. So you can deploy the policy using maven deploy. The deploy phase also has a package step. So if you only want to generate the jar, you can issue this command. But if you want to generate the jar and deploy the jar into Exchange, you can do a deploy. Now we come to the concept of inbound and outbound policies. As I said, Inbound policies, also called the source type policies, are applied to the HTTP listener, which is always a source for your HTTP flow, which gets paired to the API manager instance. But operation type policy or outbound policies are applied on each HTTP request operation that you have in your HTTP flow. But if that's not something you want for a specific HTTP requester component in your flow, you can use this property gateway disable policies true for your HTTP requester. So this is a default behavior of an outbound policy, that if you apply an outbound policy in an HTTP flow that you have paired using auto discovery, it will be applicable to all the HTTP requester component that you have in the HTTP flow. So outbound policies are quite uncommon. I haven't seen a single outbound policy provided out of the box by MuleSoft, but as part of the demo, I have actually tried out and it works. But source policies are quite common. It gets executed when your API gets invoked. Before the API gets invoked, the backend API, and after the API gets invoked, there can be steps that you can define, which can be pre-execution and post-execution, and those will get executed as a part of your policy if you apply your policy on the HTTP flow. So I'll zoom it a little bit to see a sample policy. So this is a template project. If you generate a template project, it will give you this default step. So if you see, there is a HTTP policy :source. So this is an inbound policy segment. And there is a step called execute next. So execute next, you can only have this once in your policy step. And this actually invokes your backend API or the next API in the order, or next policy in the order. So you can apply multiple policies. So execute next means it executes the next policy in the order, or if there are no other policy, it executes your backend API logic in this step. But then before this step gets executed, you can have some steps which are like pre-execution steps, and you can have some steps after this execution step. There is a concept of message propagation. I'll come to that, but there is a diagram which explains both the inbound and outbound policies quite well. I'll come to that as well. And the YAML configurations, as you have seen, it contains properties which you can configure when you apply the policies, and you can fill up the form when you apply the policy, and those values are accessible from your policy logic. So if you have a business logic that is based on these configurable parameters, you can actually access these values and define your logic in your policy configuration. And the way you do that is by a templating language called handlebars. So every property that you configure are accessible in your configuration using handlebar expression. Those become handlebar variables actually. And those are just these brackets. And I'll show you how you access those variables. And these are the types for those parameters. So it can be a string or an expression which supports a database data with expression, a boolean which can be true or false, an integer, or a radio button which shows up as a drop down, and key value pairs which can be like key value pairs it shows in the form. You can add multiple key value pairs, and in your policy logic you can loop through each one of these using this kind of expressions. But let's see how these parameters are accessible in your policy logic. So for the custom circuit breaker that we've implemented, say we have a parameter called trip threshold, and here we have used these expressions to access these variables. So there are like 3 brackets, and then you have the property name, and this is called handlebars expression. It's a handlebars variable, and the name of this variable should match the name of the property. Name of the property. Okay. Yeah. Let's go back to the slides. There is a specific extension which is provided by MuleSoft for using in your custom policy. It is called an HTTP policy transformation extension. It allows you to inject headers, add headers or a list of headers. It allows you to remove headers, and it allows you to set the request and response, which can also be done using set payload. But this extension is quite useful in manipulating HTTP headers. So when you generate a custom policy, this particular extension is by default included in your form file. So you don't need to explicitly configure it. And these policies, this plugin is available in your configuration by default. So there is a namespace defined for it and a schema location, which resolves this extension. And another thing to note is that there is no UI view of the policy logic, which is definitely a challenge when you develop a custom policy. The way I do it is that I create a test project, a Mule application. For example, I have done this custom policy, but how I implemented it, I actually implemented the whole logic in a Mule flow, locally tested it, and then I went to the XML config and I copy it, and then I paste it into the custom policy where I want to use it. Unfortunately, there is no UI, there's no visualization of the flow that you implement. You have to be familiar with the XML syntax and XML configuration. But when you develop using a Mule flow, sample Mule flow locally, you can test it as well, and you copy paste it here. And wherever you feel you need to replace a certain variable or temporary variable that you have used for testing, you replace it with a handlebar expression if you want to pick the value from the policy UI, right? Okay. So this extension is quite useful, and this is the diagram I was talking about. So if you have applied an outbound and inbound policy, say your policy can have an outbound and inbound policy in the same configuration, or it can have separate configurations, which means you can have a policy which you can have a dedicated policy for an outbound logic, you can have a dedicated policy for an inbound logic, or you can have a common policy where you have both the inbound and outbound logic, because the purpose is quite different for these two different types of policy configuration. So if, say, you have a source policy and an operation policy, and you paired this custom policy with your HTTP flow, the source gets applied to your entire HTTP flow because it gets triggered using a source, which is an HTTP listener. So if you have pre-execution test steps, that gets executed first, number one, and then you have execute next, which means your actual flow gets executed then. And then you have at a certain point an HTTP requester, which means this gets intercepted by the logic that you have for an outbound flow or outbound segment. And thereby, any pre-execution steps gets executed next, which is number 3. And then you have execute next, which executes your HTTP requester. And then you have post-execution steps, which gets executed after your HTTP requester component finishes execution. If you have multiple HTTP requester component, this policy segment will get applied on all the HTTP requester component. This is the behavior. And if you want to disable it for a specific HTTP requester, you have to use a particular configuration, which was mentioned in the earlier slide. And then finally, there is a post-execution step segment in the source policy, which gets executed at last. Now comes the concept of a message propagation. So message propagation is by default there for certain steps and not there for certain steps. For a source policy, message propagation is by default for post-execution steps, which means if you manipulate your HTTP request here in this segment and here in this pre-execution step, it happens by default. I'll give you an example. If in an operation policy, you have done a header injection in pre-execution step, when HTTP requester gets executed, those additional headers get injected here in your outbound call. And in the source policy, the pre-execution step is not allowed to manipulate your HTTP request. If you change the payload here, the original payload which was sent will be sent to your HTTP flow. Any changes that you make here will not be reflected in your HTTP flow. However, if you make any change in the post-execution step of a source type policy, the message propagation happens by default. So if you have a set payload here, and you have a payload which gets generated as a part of your flow execution, this step will replace that payload. The message propagation will be applicable here. But in step 1 and 5, if you want to achieve message propagation, then you can use this property called propagate message transformation equals to true. Okay, so that's all about the concepts of custom policies. And we can go directly into the demo now and see custom policies in action. But before that, it's better we try to deploy a custom policy and see how the deployment works. So, for example, we have a custom policy which got generated in my local folder, and Maven is installed in my local folder, so local machine. Sorry. Sorry. So this has my project. So this is the root folder of a custom policy that I have created, and I have implemented this policy. So as I said, every time you deploy or make any change in your policy, you need to do an increment of your policy version. So now I've deployed, say, 14. I can change it to 15 because I'm trying to deploy it again. And in any point exchange, just to see this policy exists and what is the latest version. This policy exists. The version is 1.0.14. And let's try to deploy. As I said, we can just issue the command maven deploy. It should deploy in your exchange. So there you see, it generated the jar. Then it has installation steps where it puts the jar as a dependency in your local, and then you see this artifact into exchange. So we are deploying the version 15. The final step is deploy file. Let's wait for deployment is finished. Now let's refresh it and see if the version arrives. See, the version has arrived 15. And this version will now be available in your API manager for applying in your policy instance. So let's now, so now you saw how a policy gets deployed into exchange. In Mule, 4 policies are shared via exchange, and API manager will always be able to look up from exchange. Let's see what we have implemented as a part of our demo. So we have implemented circuit breaker as part of our demo today. A circuit breaker is discussed. So I've taken the diagram from Martin Fowler's website. You can always read through it. Martin Fowler is a very globally renowned architect and an author. He describes a circuit breaker like this. A circuit breaker, as you know, it prevents your process from getting overloaded in a certain condition where you have, say, a backend, your API has a backend service it invokes, and that backend service is down. So if you have client applications which keeps invoking your API when there is an error, it will bombard with a large number of transactions which can bring down your API. So you might want to close the traffic if a certain criteria is met. Say, you can define, like, if we have 10 errors in a period of 10 errors of a specific type, service unavailable type of error in a period of 60 seconds, I want to block the traffic for next 60 seconds. So in this kind of requirements, circuit breaker helps a lot, and you can actually close the traffic. So when you say the circuit is open, it actually blocks the traffic. When the circuit is closed, it allows the traffic to flow through. But Martin Fowler also describes a state called half open, which means when you have a circuit open for a while, there is a timeout or reset timeout. Means you cannot just keep your circuit open forever. It might be open for say 60 seconds, and after that you will again allow traffic, but you don't allow the traffic to bombard again. You go from an open state, you should always go to half open state, and in a half open state you will allow that one transaction to hit and see if your backend is up. Only then you allow rest of the transactions to flow through. Otherwise you again go back to your open state. So that's the typical circuit breaker implementation. What I have done, I've created a sample API and I've deployed it into my Mule runtime. This is the API. The code is there in repository. You can always clone and see the code. What this API does, so this is the API logic. What this API does, it takes an HTTP status and it replies with the same status back as a response. So if I want to mimic a 401 error, I call it unauthorized, it gives me 401 error. If I want to give 503 service unavailable, gives me the same error. And the reason why we need this API is to simulate the backend outage when we want to apply the circuit breaker. And this circuit breaker policy is applied on this API through API manager. And let's go to the API manager to see how we applied the policy before we actually execute and see the circuit breaker in action. Okay, so this is the policy. You can see it as active, so it is paired with the deployed instance. And in policies, takes a while to come up. Yeah, we have applied the circuit breaker policy, which is a custom policy that we implemented. And if you click edit, these are the form parameters that I was talking about. We define these parameters in the YAML file, if you remember. And we have defined these parameters. And what are these parameters? Let's see. First is a trip threshold. So how many errors will allow? Say we'll allow 10 errors in a period of 60 seconds. And if we pass this number, we'll open the circuit. And what will be the open timeout? How long the circuit will be open? It will be open for 60 seconds. But if you see some errors like 401, these are business errors, like unauthorized, or 500 is a business error. We don't need to really open the circuit for those kind of errors. So you can specify for which error codes qualify for your circuit breaker criteria. So this is always you can customize according to your need. So I have mentioned 504 gateway timeout and 503 service unavailable type of error to qualify for my circuit breaker. And I've applied this to all the resources. So if you see, this is a resource level policy. By default, any HTTP API or any API that you define either with YAML, without YAML, it will in Mule 4, it allows you to apply on specific resources. So I will not reapply it, I'll leave it, but you have seen what we have configured. So let's see the circuit breaker in action. As you can see, I can simulate errors in the API by passing this particular parameter, telling the API what error to throw. If I tell throw a 503, it will throw a 503. So as I said, if I give 200, it's a success, and it actually retrieves some data. Yeah, I'll come to that. What data it fetches is part of the second demo. If the time permits, we'll go through that. And if I say 503, it actually throws a 503 error. So there you see one error has happened, but we have said the error threshold is a 10. So let's hit 10 times. 2, 3, 4, 5, 6, 7, 8, 10. 10 has crossed. 11th one should open the circuit. Let's see. Yeah, the circuit is open, and which means now your API is not hit. Before the API is hit, your circuit is open and the traffic is blocked. You should go through the implementation logic. I'll not walk you through the code because in the interest of time. But what it does, it actually stores the state in an object store, because it's definitely storing the state, how many errors are happening. So it is storing the state, and based on that, it decides whether the circuit breaker criteria is met, then the circuit is open. And it also tells you for how long the circuit is open. So you can try hitting it. It's open for 48 seconds, almost done, because we mentioned we'll hit it with a success this time. So after the open timeout happens, the circuit is closed, the traffic should be allowed to flow through. So let's see, I think 60 seconds have passed. Yeah, 60 seconds have passed, the circuit is open again, but it was blocked for 60 seconds because if you have seen when we applied the policy, we mentioned, okay, I want the circuit to be open for 60 seconds, but now we can test the half open state. If you remember what's the half open state. Yeah, we'll hit it 10 times. Yeah, so let it be there, and now you can see the circuit breaker in action. We'll see how the this half open state works. It is also implemented in the same way. It's all part of the policy logic. And if you go through the policy logic, the code is there in GitHub. You will know what has been implemented. So we have to persist the circuit breaker state. One thing you need to note is that this particular name of an object store, if you mention it as a persistent and you use it as an object store v2, for example, if you're deploying your code into Cloud Hub, your workers would share this state because you don't want the circuit breaker to be applicable on individual workers. You want a common state. So you need to click the object store v2 for that. This name should not conflict with any other object store that you have in the itself, because then it will conflict and your policy you won't be able to apply your policy, which makes sense because this policy logic also gets executed in the context of your application in the in an embedded API manager or a wrapper component. It's one thing to note. And since there is no UI configuration available, you need to actually, if you're using modules like object store or HTTP, you need to include those in the include the namespace and the schema location. So I have included, say, this :OS. This is the namespace for object store connector. So you can always reuse all the mules of connectors that you have. You need to also include that as a dependency in your form file, right? So I believe 60 seconds have passed. So this particular instance, I think 60 seconds have passed. So we'll allow to hit the API once and see if the error is still the same. Then it will open the circuit. So let's hit it. You see, it actually hit the API. Your circuit is open. But when you hit the API now, it goes into the half open state, which means in the half open state, you got an error, which means you still don't qualify for opening your closing your circuit. So if you try to hit it now, it will say circuit breaker is open again. So from a half open, it goes back to the open state. So this is an outbound policy. We still have some time left, so we can I can also show you an outbound policy which I have implemented. So the outbound policy is the Salesforce OAuth token injector policy. As outbound policies we have discussed, it gets applied on every HTTP requester component in the HTTP flow that you pair with your API instance. And if you go to API manager instance, you'll see I have applied the circuit breaker and I have applied the token injector policy as well. This policy does your housekeeping of calling your Salesforce login API, gets the token, stores it into your object store, refreshes it periodically, and injects it to every outbound Salesforce REST API call that you make from your Mule flow. If that makes sense, that's how it's implemented. And if you see, what we have configured this policy with is a set of parameters like this. So it takes a Salesforce username, password. As you know, for accessing Salesforce REST API, you need to create a connected app, and connected app will give you a client ID and secret. And you can also mention as a part of this policy, like what is the time period in which you want to refresh the tokens. So here I have mentioned, okay, every 15 minutes you refresh the token. And if you see, for our success response, actually it should be open, closed now. If you see, in our success response, I was actually calling a Salesforce endpoint and fetching an account details, for example. And how I have implemented in the flow, I'll go to this sample API. This is just a simulator used for the demo. Here I have called a subflow. Inside subflow, I'm actually fetching a Salesforce account. So I've given the URL. Things are hard coded, spare that, because it's just used for demo. And in headers, if you see, I haven't injected anything. There is no OAuth token injected in the header. But when I called the API, it was able to call the REST API and give me a result. If you try doing that from Postman, say there is, if you try to not pass the OAuth token and fetch the account, it will give you an error that it doesn't have the OAuth token. But when I called it from my sample API, I was able to get the account details, which means our outbound policy is able to inject the tokens into the API. Okay, so that's part of the demo as well. You can that code is also there in GitHub. It's a public repo. Please feel free to clone it, see how it's implemented. I can show you a glimpse of it. In the form file, if you see, I've used the object store again, because we need that as a part of storing the tokens and refreshing the tokens. And in the policy logic, we have actually done a check for the policy token expiration, and we have actually called the login API, OAuth token login API. And after fetching, and if you see, these handlebar expressions actually fetch the credentials which you configured in the policy UI, and it actually applied those credentials when it made a call to the Salesforce login API, and then it fetches the token, stores it into the object store, maintains it, and injects it every time it makes an outbound HTTP call. So let's see where it injects it. It injects it here. See, and I use the HTTP transform extension that we discussed about earlier in our presentation. So what it does, it actually injects an additional header. And if you remember, in the flow, an operation type policy always does a message propagation in pre-execution step. The post-execution is not default unless you say that you want to do message propagation. So if you see the code here, I have mentioned propagate message transformation true, but even if I had not given this property, it would still work because I'm not doing any manipulation after the policy execution. I'm just doing a log that, oh, my custom policy has finished execution. If I want to manipulate something here so that that Mule message context is available down the line in the policy order, in the next step in the flow, then I would have actually mentioned the message propagation true and manipulated the HTTP request here, but I haven't done it. So that property is not useful here. But here you can see using an HTTP transform headers, I'm injecting an additional header in the outbound HTTP call. And that's why I'm able to fetch the account details. Even when I haven't done any OAuth token maintenance or any calls to get the token or anything, I just called a Salesforce API, and my outbound policy handles all those calling login API, storing the API, injecting it into the header when you make the call. Everything is done by my outbound policy. I'm not suggesting this is how you should call the Salesforce REST API. I'm not recommending that. It is something that I did as a part of demo just to demonstrate how the outbound policies work. Okay, so that wraps up the presentation for today, and I believe you learned something out of it. We'll go to the question answer session probably.
Great, thank you very much for that, Susmit. We do have a few questions that came in the chat during the presentation. So what I'll do is I'll cover a few first that I've curated. For everyone else who does have new questions, feel free to enter them in the chat from now on. So the first one is, can I apply multiple versions of custom policy to the same API?
Yes, you can. Same version cannot be applied multiple times, and that's why we can see. So if you go and you want to apply the same policy, you can select category custom, and say I have applied 14, so it's disabled, but 15 is the new version that I just deployed in front of you, so I can apply that. And you can apply different versions of the same policy in the same instance. Okay, that is also allowed.
Correct. Thank you. So yes, we have another one. Can you invoke a separate template2.xml file within template.xml? And the context is in case we have to segregate the logic into different.
No, you cannot do modularization. I haven't tried that, but as far as I know, you cannot do that.
All right.
But within the configuration file, you can have a source type defined and an operation type defined. You can have only operation type or only source type, or you can have mix of both.
Thank you. I have a question. Can we use subflows in custom policy flow?
No, it's the same question, same type of question. Yeah.
And we have, can we have a HTTP listener in the policy template.xml? If so, will it be invoked automatically when the policy is applied? And how do we do port configuration?
I haven't tried that, but logically it makes no sense to have an HTTP listener.
Fair enough. I thought the same thing as well, but I thought it would be good to check. So we had a couple of people asking for the GitHub URL. All of them, I replied on the chat. Yep, that's fine.
This is there in the slide. So this is a trial account, you can see. So anyone can try this. You can try applying the policy, and if you require the Postman scripts also, I can share.
Excellent.
I'll upload in the GitHub.
Thank you. I have another question here. How do you add drop-down value types fields in the YAML? Is it possible?
Yes, it's possible. You have to define radio type, and you have, it's like an enumeration, so it will show up as a drop-down. Yeah, so if you see the custom policies documentation, it talks about those types. So you can try it.
I have another question here that is a little bit wordy. So what I'll do is I will post a link in the chat for you, Susmit, and if you could open this last link from the chat, it's just where we have our Q&A consolidated in the one page. And if you could scroll right to the bottom, that would be the question that I'm looking for a bit of guidance on. So right to the bottom. Yep, that's the one by Emir.
If the circuit breaker is open, it will still go through the listener and logger, right? To block. So your policy, your outbound policy logic acts as a wrapper on the top of your actual backend API. So if I can go back to the flow, probably this one is better. So if you have an HTTP flow, you have a wrapper logic in that pink ones. So you have a pre-execution steps which gets executed before your flow gets invoked. So circuit breaker blocks your traffic in step 1. So it doesn't go to step 2. I hope that answers your question. So you asked whether it goes to step 2. If I understood the question correctly, it will go through the listener? No, it will not. So it will be blocked in step 1. If you see the policy logic, you can go through the implementation how I did, and you will see that it blocks the traffic, and the execute next step never gets executed when the circuit is open, which means your actual API doesn't get invoked. And that's what we want to do, basically. That's the purpose of having the circuit breaker in place. So it blocks the traffic in the policy logic itself.
Excellent. Thank you. Amir says thanks for that response. He gets it now. Suruchi, your question about object store and TTL and expiry, I think that's, well, actually it's relevant now. So the question is, there's a little more to the question that she put in the chat, so I'll ask it verbally. So can we change?
Yes, I think she asked about additional.
Yes, can you dynamically configure it from a YAML field?
I kept the default one. It's dynamically configured. Yes, you can take it from the YAML and apply handlebar expression here. So the thing is, how the concept is that the handlebar is a templating logic. So before your actual XML configuration gets loaded and executed, the template logic gets executed first. It replaces all the values. Then your XML config gets loaded, and your beans get created, and then your execution starts.
Great. Thank you, Susmit.
I hope that answers.
We have another one. This one's from the chat. So can we apply this circuit breaker logic just to the HTTP requester as an outbound policy? And if so, what changes will you need to make in the current existing code? This is from, yeah.
So yes, so this policy is an inbound policy, the one which is demonstrated in this presentation. But if you want to apply a circuit breaker for an outbound policy, probably you can do that as well.
Thank you.
Because the Mule message context is available in the same Mule message context is available in the policy logic as well. So I'll show you something. Probably that this will answer the question. And I understand why this question is asked. So if you see, at some point in the code, there is an execute next, which actually executes the policy, but then it checks whether the response is qualifies for the circuit breaker or not, and that is done via a try catch block. So any error, so you see this is the try catch block, which says if your circuit breaker profile configuration says that this is a list of error codes that qualify for your circuit breaker criteria, and there you see the attributes of status code, which is the actual error code thrown by your HTTP flow that got propagated down to your policy, and you could handle the error in your policy. Your policy is able to detect what error is thrown from the policy. So it gets the execution context, the Mule message gets propagated.
Thank you, Susmit. We have another question on how do we sequence the execution of policies if we have multiple policies?
I think that's available in the edit policy order.
Yep, as far as I know, it's the edit policy order as well. So from top to bottom.
Yeah.
We have a couple, I think Suruchi on the chat had mentioned that she's having some errors around what she's trying to implement. I just gave some advice around if you do have issues, please either use the MuleSoft support channel or the MuleSoft forums. Susmit, if people do want to contact you for whatever reason, what's your preferred method of engagement?
Yeah. You can contact me in LinkedIn. That's a public profile. Please add me, and we can always collaborate.
All right, we are at time, so I will want to thank you, Susmit, for taking the time and effort to prepare a very comprehensive presentation. For everyone who's joined us on online today, please give your feedback for things you liked and things that you think could be improved. We're very glad that you chose to spend the time with us learning about custom policies today. If there is anything else in terms of general meetup feedback, feel free to, again, leave that in the comments or contact us as the organizers. Just a reminder that the slides and the recording for today's event will be posted on the event page. So that's the page on meetups.mulesoft.com, the one you used to join this meeting. And I'll be aiming to post that within the next 24 hours. Our next meetup is going to be next week, and it's going to be in a different time zone and different time slot. So it will be hosted out of EMEA, which is London specifically, and it'll be with Angel. So it's going to be multiple topics in that one. It's going to be a little bit different, but we're hoping to make it just as exciting as the one we've had today, if not more. So with that, thank you very much for dialing in. And I hope you have a wonderful rest of the day. Thank you.
Thanks everyone. Thanks, Rajton. Thanks everyone for joining. Thank you.